Hello everybody. In this video we are going to derive Heron's formula. This formula is credited to Hero of Alexandria, the Greek mathematician, and the proof can be found in his book Metrica. So what is Heron's formula? Heron's formula gives us the area of a triangle when the length of all three sides are known, using this formula, where S is the semi-perimeter. Let's go ahead and see the algebraic derivation. There is trigonometric and some other alternative derivations as well. Today we're going to use algebraic derivation. Let's start by constructing triangle ABC. And in this triangle, sides are little a, little b, and little c across the vertex A, B, and C respectively. We can construct the height in this triangle. From vertex A, we can drop the height, and we can call this point D. Height is h. Let's call this distance from B to D L. So from D to C will be A minus L. Now, in triangle ADB, we can apply the Pythagorean theorem, which is h squared plus L squared is equal to C squared, the hypotenuse of the triangle ADB. And if we solve for h squared here, h squared will be equal to C squared minus L squared. Let's call it equation 1. Similarly, in triangle ADC, we can apply the Pythagorean theorem, because this is a right triangle. So h squared plus a minus l, the quantity squared, equals to b squared, the hypotenuse. And if we solve for h squared here, we obtain b squared minus a minus l, the quantity squared. And let's call this equation 2. Height is equal to height. So we can set equation 1 equal to equation 2. So we have C squared minus L squared is equal to B squared minus A minus L, the quantity squared. We can expand this using the identity A minus B, the quantity squared, is equal to A squared minus 2 times AB plus B squared. In our case, our A term is A and our B term is L. So let's expand as A squared minus 2 times AL plus L squared. And we can distribute negative sign into parentheses. C squared minus L squared equals to B squared minus A squared minus 2AL becomes plus and minus L squared. So we just distribute the negative sign into each terms. Now we have negative L squared on both sides that we can equally eliminate. Now we're going to solve for L. So we can add A squared, subtract B squared on both sides. So, and then divide by 2A. So what we obtain is A squared plus C squared minus B squared over 2A. Now we know L in terms of A, B, and C. Now we can plug our L expression into our first equation. So we have h squared is equal to C squared minus, instead of L, we're going to use this expression. A squared plus C squared minus B squared over 2A. And we have square. This is in the form of A squared minus B squared, which is the difference of two squares, and we can factor it out as A minus B times A plus B. So we're going to apply the same here. This is like our A term here, and this is like our B term here. So h squared is equal to c minus everything times c plus everything. Now we can merge this fraction and c, similarly this fraction and c. We multiply, use the sign, so h squared is equal to c times 2a is 2ac minus everything else here divided by the same denominator. We'll merge similarly 2 times ac plus, we don't need parentheses because this is a plus sign, all over 2a. Now we need to distribute the negative sign into parentheses. So we obtain h squared is equal to 2ac minus a squared minus c squared plus b squared over 2a times 2ac plus a squared plus c squared minus b squared over 2a. Now we can multiply the denominators and pull it out. So h squared is equal to 1 over 4a squared if we multiply these two. Inside we can rearrange by grouping this. So we have b squared, and we can factor out negative sign here. So we have a squared plus c squared minus 2ac times, we can also group this trinomial here. So we have 2ac plus a squared plus c squared minus b squared. Here we're going to use the identity a plus b, the quantity squared, is equal to a squared plus 2 times ab plus b squared, which is this expression. A squared plus 2 times ac plus c squared is the expression of a plus c, the quantity squared. So instead of this trinomial, we can write a plus c, the quantity squared. And instead of this quantity, this trinomial, we can use a minus c, the quantity squared, because it is this identity here. Let's rewrite everything clearly. So h squared is equal to 1 over 4a squared, b squared minus a minus c, the quantity squared, times a plus c, the quantity squared, minus b squared. This is again difference of two squares, as in the form of a squared minus b squared. Similarly, a squared minus b squared form. So in this difference of two squares, our a term is b, our b term is a minus c together. Our a term is a plus c together, and our b term is b. So we're going to factor it out as in the form of a minus b times a plus b. So h squared is equal to 1 over 4a squared. Now we can rewrite this expression in the form of a minus b times a plus b using difference of two squares. Our a term is b here, so b minus our b term is a minus c times b plus a minus c. So we use 1 minus 1 plus, as in here 1 minus 1 plus. So we're done with the first parenthesis. For the second parenthesis, our a term is a plus c minus our b term is b, and we're going to alternate it, a plus c plus b. Now we can distribute negative sign into parentheses. So h squared is equal to 1 over 4a squared b minus a plus c, b plus a minus c, a plus c minus b, a plus c plus b. Now in the Heron's formula, we said that semi-perimeter S is equal to a plus b plus c divided by 2. In this equation, if we multiply both sides by 2, we obtain 2s is equal to a plus b plus c. If we subtract 2a on both sides, we don't change the equation. So 2s minus 2a is equal to a plus b plus c minus 2a. Now we can factor out 2 on left and b plus c. Negative 2a plus a is negative a. So now we know b plus c minus a is equal to 2 times s minus a. So we have b plus c minus a here. So we can rewrite 2 times s minus a instead of this expression. Similarly, we can derive the other forms. So instead of subtracting 2a, we can subtract 2b on both sides. And factor 2 out on left. So we obtain a plus c. Negative 2b plus b is negative b. So this expression is equal to 2 times s minus b. So a plus c minus b is here. Instead of this, we write s minus b. Let's continue deriving this. Instead of subtracting b, let's subtract 2c on both sides. 2s minus 2c is equal to a plus b plus c minus 2c. And we factor 2 on left. S minus c is equal to a plus b. Negative 2c plus c is negative c. So a plus b plus negative c is equal to 2 times s minus c, which is in this 2 times s minus c. And we said that a plus b plus c is equal to 2s. Now let's rewrite everything in terms of s. Now we obtained this expression. Now we can simplify further. 2 times 2 is 4, cancels this 4. So we obtain h squared is equal to, we have 2 times 2 is 4 above, and over a squared in the denominator, and we have s minus a, s minus b, s minus c. Now we can take the square root on both sides. So h is equal to 2 over a square root of s minus a, s minus b, s minus c. So this is height in terms of a, b, c, and s. Now we said that area is equal to 1/2 base times height. So we're going to plug in this height in our area formula. And in the triangle we had, in our triangle, our height is this expression we found, and our base is a. So area is equal to 1/2 times base, which is a, this is our base, times height. Instead of height, we're going to use this expression we derived. So here 2 cancels 2, A cancels A, so the area is equal to our Heron's formula. So this is the Heron's formula we derived using the algebraic method. So we have a small warning here. If you have a very thin triangle where 1/2 of the sides approximately equal to S and the third side is much shorter, Heron's formula may not be accurate. So if your triangle is like very thin, that 2 sides are almost equal to S and the third side is much smaller, like this, so Heron's formula might be inaccurate. So be careful about that. Other than this special situation, Heron's formula is good to find the area. Thank you for watching.